Okay. All right, so derivatives of trig, right? Everybody's favorite, trig. So as long as we're talking radians, and we need to always be talking radians when we are graphing or doing algebra with our, well, not algebra, trigonometry and calculus, we need to be talking radians. Then the derivative of sine of x is, and by the way, this is in the reference sheet, it is, the derivative of sine x is cosine x. So interesting. And no, I'm serious, that sounded sarcastic. No, I think it's incredibly interesting. And the derivative of cosine, it would be incredibly, I don't know, elegant or symmetric if it was sine of x. It's not, but it's close. It's negative sine of x. So neat. And you know, it's not here, but darn it, I like it so much. Let's figure out what the derivative, let's say if f of x is cosine of x, no, excuse me, negative sine of x, I wonder what its derivative would be. Well, the negative 1 on the front is a constant that's just going to come along for the ride. So the derivative of negative sine of x is negative cosine x. And then lastly, if f of x were negative cosine x, then its derivative would be the derivative of cosine x with the negative 1 on the front. The derivative of cosine x is negative sine x. So it's negative sine x with a negative sign added to the front of it becomes positive sine x.
Easy.
So these things have a cyclic nature to their derivatives. Not only do the functions' graphs repeat themselves, but the derivatives repeat themselves. Very neat. This in this box is on the reference sheet. I mean, those over there are not. Those are just for interesting purposes. Or you never know when you might need to do something like that for a test, you know.
Hint, hint, hint.
So let's do some derivatives. We'll start with x times the sine of x. And you notice I said times. That means we're going to have to deal with a product rule. Product rule, u prime v plus ub prime, where u is x and v is sine x. Well, u prime is simple. That's just the derivative of x. That's just 1. And v prime, the derivative of sine of x, is in our box up above, cosine x. F prime of x is u prime v plus u v prime, or just sine x plus x cos x. Boom. Done. Simple. You know, I don't really think that you guys dislike trig. What I think you dislike is having to evaluate trig.
No, we just like because we didn't understand it.
No, you mean because you didn't memorize the things I told you to memorize.
What was the test average for that again?
Like I said, you didn't memorize the things I told you to memorize.
30, 60, 90.
The 30, 60, 90, and the 45, 45, 90 are necessary. That's okay. You'll get another shot at it.
I just, not the properties. Remember when we had to, okay, remember
Like the sine 2x. Like
Yeah,
that.
like-
And
The identities. Don't worry. They're on the reference sheet. You don't have to memorize them.
I memorized triangle, but I forgot.
It's okay. We will review it all. We will review it all. Oh, by the way, I created a brand new derivatives test. A brand new derivatives test, which is good news for you because that means I get to give you my old derivatives test as the review. Because I didn't have, because you know how I like to give you old tests as reviews? I didn't have one. So I made a new test, so I now have an old test that I can give you as a review, and now you can have an actual sample of IB questions.
No, thank you.
All right. Let's tackle 4 cosine squared 3x. This one is going to involve chain rules. No product rules this time, just chain rules. it might be difficult for you to see where those chain rules are happening though. So I tell you what I'm going to do. I want to rewrite this so that it makes it easier for you to see what's actually going to happen. The 4 is outside of the cosine. Interior to the cosine is the 3x though. There is the square. When you say cosine squared of some angle, what you're saying is, hey, what is cosine of that angle? And once I get the result, I will square that result. That's what that says. So if you write it like this, it should be much easier to find the derivative. So yeah, chain rule. It's actually a double chain rule. Double chain rule. So we will start by finding the derivative of the outside. The outside, I forgot to write f prime, sorry. The outside is 4 times something to the second power. So when you talk about the derivative of the outside, we're talking about using the whole exponent dropping to the front situation. So I'm showing the work. What we're going to have is a 4, a 2 dropping down to the front, not touching the inside of those brackets. So it will still say cosine 3x, but this exponent would have dropped from a 2 to a 1. And that's why I don't have brackets anymore with the power of 1 on them. That would just look dumb. But now we have to do...
If you did put the brackets on with the power of 1, would it go in front of the 2?
It would go in front of the cosine.
Why is the 2 now?
Because the 2 is part of an outside structure where it's dropping down to the front.
So could you, in theory, just put it like 8 cosine 3x right now?
Yeah, I'm just showing the work. I didn't want to write 8 and someone say where to come from. I'm going to simplify it just to say. But if you could do that, that's fine. I just want to make sure that all the steps are shown. Now we have to multiply by the derivative of the inside. The inside of the brackets is a cosine structure, cosine of some stuff. The derivative of cosine of some stuff is negative sine of some stuff. Negative sine of, and don't you touch its argument. But the derivative of the argument is not 1, so we do have to also do times the derivative of the argument, which is a 3. So that is a double chain rule. We can clean this up. We have a 4 times 2, which is 8, and then we have a negative 3, so that's negative 24 on the front. Negative 24 cosine 3x sine 3x. It's this negative right here. That's the derivative of this argument. Okay, hold on. Okay, look. Here, the green structure, all of that is happening here. The red structure is happening here. And the purple structure here. What is the derivative of cosine of x?
Oh, you put on the 24,
Okay. So what we did was I tackled the green structure first, not worrying about what its inside is, bringing the 2 down to the front, not touching the inside of the green structure. Here's me not touching the inside of the green structure. But this exponent did decrease by 1. I didn't write it, but I could have, snuck in a bracket system right here. But its exponent would have been a 1, so it was unnecessary, and that's why I didn't write it. Then we had to tackle the derivative of the inside of those brackets, which is a red structure. It's a cosine of some crap. The derivative of cosine of some crap is negative sine of that crap. And then you have to do the derivative of that crap, which is derivative of 3x, which is where this purple underlined 3 is coming from. And then 4 times 2 times 3 times negative 1 is negative 24. Yes, ma'am?
Well, is that negative sine?
Yeah.
Does that, could you have not put on the 24 and put it, kept it in front of the sine 3 above?
If you were going to do that, you would need to have the parentheses there still to imply that you're multiplying by a negative and not subtracting.
Okay.
See, this is all multiplication.
Yeah.
So if I just put If I just put the minus sign right here, it would have looked like subtraction, and we don't want that. So if you're going to leave it in parentheses, ew. Why would you say an answer is 2 times 3 when you could just say it's 6,
Yeah.
Just treat it as a constant and just get in the habit of moving your constants to the front if everything is multiplication.
Okay.
It'll make your life easy. And that's all we have to do for that one. That's why I was saying that's all I have to do for that one. But this is a double angle identity that I could mess with, but I'm not going to. If you care, it's negative 12 sine of 6x. But you don't need to know that. You don't need to know that for this test.
How convenient for my head.
Anyway, but yes, it is. Yeah, it is a double angle, Ethan. That's what I was saying. We don't have to go further. We could. Why would I ever want to? In case a question said you had to, right? But I'm telling you right now, there are no double angle identities on this test. If there were, I would have warned you. Alrighty. Chain rule inside a chain rule. I like it. I like it a lot. Would it be helpful for you guys to see the chain rule happening if I just went ahead and wrote the question in different colors instead of underlining? Would that be useful? Okay, then I will do that. What we will say is that f of x is, and I'll rewrite it in colors. The exterior most structure I'll do in green. It is ln of some stuff. Now the interior part is cosine. I'll do that in red. Cosine of some stuff. I know there's no parentheses around that 2x, but it'll help you see the chain rule if I do it that way. And then the 2x I'll color purple, like that. So since there are 3 colors, I have a double chain rule. We'll tackle the green stuff first. F prime of x is the derivative of any ln is going to be 1 over its inside. So the derivative of the green will be 1 over its inside, cosine of 2x. But then the chain rule says that you have to do the derivative of that inside, which is the derivative of cosine, which is in red. So times. So far, so good? The derivative of red cosine is negative sine of some stuff. But the chain rule says you also have to do the derivative of that stuff, which is the derivative of purple 2x, which is just 2. So if you want it, before I simplify it, which really doesn't simplify much, before I simplify it, would you like to ask me about where any of the parts came from? Let's hear it. Of the logarithm, yes. Oh, I just left it green because I was showing you that when you find the derivative of the green thing, you don't do anything to its argument. It's just 1 over argument, and then times the derivative of that argument. No, a derivative, it just says, it's just because no, it's not on the bottom. It's next to it, which implies it is actually on top because, I could have said this is over 1 and this is over 1. Yeah, it doesn't go to the bottom. Okay. Yes, Bria?
Wait, so this isn't a product?
No, this isn't a product rule.
Would it be a product rule or is an x after the ln?
If there was an x sitting back here, this would be a product rule question, yes. But it would be a horrible product rule question because this would be u prime. It would be terrible. So cleaning it up, and like Alberto and I just discussed, this red and purple information is not on the bottom of the fraction. So negative sign in the front, 2 in the front, negative 2 sine 2x over cosine 2x. Could we use an identity here? We could. Somebody whispered it. Tangent is sine over cosine. Now we don't need to do that for this test. But this does equal -2 tangent 2x. Isn't that neat that the slope of the natural log of the cosine of 2x is -2 tangent 2x? So neat. Stop it.
I'm stretching. Can I do the next one?
No.
Okay.
Hey, speaking of tangent x,
He said no.
you guys don't have the derivative of tangent x. By you guys, I mean my IB juniors. I mean my former IB juniors, because Gianna probably does have the derivative of tangent of x memorized because it's part of AP Calc. Yeah? You have a question for me? Yeah, it's this negative sign and this too because they're on top. I don't understand your question. Where would your 2 have ended up? I know what you're saying. You wrote negative sine 2x times 2. It's not wrong, it's just odd. As long as they didn't dictate how the answer had to be written, you'd be okay. So yeah, like I was saying, you don't have the derivative of tangent x memorized, so how could you possibly find it? Break it up. How would you break it up?
Sine over cosine.
Yeah, tangent x is sine x over cosine x. So if we want to find the derivative of that, we get to use the quotient rule.
No.
Quotient rule, u prime v minus uv prime all over v squared. U is sine x, v is cos x.
U prime equals.
I got this, Gavin. U prime is cosine x, v prime is negative sine x. Suck it in, math. Gotta get skinny.
Wait, I'm so confused.
What are you confused by, Gavin?
What it's gonna turn out to be.
You'll see in just a second. Okay. U prime v, not taking any shortcuts, not skipping any work. U prime v plus u v prime.
Oh, wait a minute.
Isn't it supposed to be minus?
Didn't this just.
Yes, sorry. Minus, good catch. Did you see how I stretched it out? I was like times u v prime because I was wondering where my negative sign went. Okay, because I already know what the answer is supposed to be, and I was like, something's not gonna work out right here. Okay, thank you. All over v squared, which means cosine squared x.
Oh, wait. This is.
Cool. Well, hey, cosine times cosine is
Cosine x squared.
cosine squared x,
Oh.
and minus minus is a plus, and sine times sine is sine squared x. Big. And why is it 1 over cosine squared? Because this is the Pythagorean identity that cosine squared plus sine squared equals 1. 1 over cosine squared x is the derivative of tangent x as far as IBSL is concerned. Hold on. Gianna, did you hear that? The derivative is 1 over cosine squared x. That's how they'll expect you to use it. It's not wrong to say secant squared x. It's just that they'll design questions around this derivative. And the reason why I'm making a big deal about that is because d dx of tangent x equals 1 over cosine squared x. This is, don't worry, on the reference sheet. It's on the reference sheet.
Can you tell me why cosine squared x plus sine squared x equals 1?
I would be happy to re-explain that to you when we review how to do trigonometry.
A squared plus b squared equals c squared.
Oh, thank you. That makes so much sense now.
Anyway,
Doesn't
Okay.
trig always add up to 1?
no.
I
Kill me.
understand now. Thank you for
So yeah, this black box down here, this is on the reference sheet. When I finish the notes, I would be happy to Gavin, when I finish the notes, I'd be happy to re-explain to you and everybody else that forgot why that adds up to 1. Because I need to draw a picture, okay?
I like pictures.
Alrighty, here we go, my golly. Look at this thing. Alright, yo, that's a little scary.
It's like trading.
But that's okay, because here's what we're going to do. If I rewrite this in a better way for myself, it's a chain rule inside a chain rule, yes. It's a double chain rule. So here's what we're going to do. We're going to remember that this square root bar is actually a 1/2 power, right? And we're going to remember that this 3 right here means that we have a sine function to the 3rd power. So I'm going to have, and then I'll color it, okay? So right now I have a sine of 2x, and that is being raised to the 3rd power. And then I'm taking the square root of that, so that it's raising that to the 1/2 power. So this cleans up, because if you remember your algebra 1 rules, what happens when you raise a power to power? What do you do with those exponents? You multiply them. So here is our function. Here is our function in colors. I think I did the outermost structure in green, correct? Green, 3/2 power. Then I went to red, sine of, and then I went to purple, 2x. So because I have 3 colors, once again, I will have a double chain rule. Yes. If you didn't combine the 1/2 and the 3, yeah. You'll get the exact same answer, but it'll be uglier. Because you'll have a 3rd chain rule. You'd have a triple chain rule. You really don't want to do that. If you can combine your exponents, please combine your exponents. You don't want to do that. It's just not fun. Okay, let's track down our derivative. F prime of x is derivative of the green structure. Well, that's just something to a power. Bring the power to the front. Do not change the inside. And decrease this by 1, so you get a positive 1/2. Now we have to do the derivative of the red stuff. The derivative of sine of some crap is cosine of that crap. And then, of course, we have to do the derivative of the cosine crap, which is on the inside, so just times 2. I would like to clean this up before I have to do anything. What I'm seeing right now is a divide by 2 and a times 2 that'll cancel each other out. So I don't need to worry about that. So I have the times 2 and the divide by 2 canceled. This 1/2 power is a square root. I am going to, multiplication doesn't care about the order, but I am going to move this cosine of 2x to the front. That way nobody thinks that it is underneath the square root bar. What we're going to end up with is the 3, and then I'm going to say cosine of 2x times the square root of sine of 2x. That's its derivative.
That was beautiful, actually.
And no identities that I know of are going to help us there. All right. One more chain rule within a chain rule. One more chain rule within a chain rule, and that is right here. Now, because I don't have the space that I need to do all of this colorful magic right here, I'm just going to rewrite it down here and go from there, okay? So we've got question, this was E up here, and this is question F. I started with E to the tangent of 4x. So time for some colors again. The outermost structure I've been doing in green. The outermost structure then will be E. The quote-unquote inside of the E structure is tangent of some stuff. I've been moving to red for that. However, tangent also has an inside. This one's 4x. Like that. So again, chain rule within a chain rule. And we are going to use the derivative of tangent to be 1 over cosine squared, because that is in the reference sheet. That's why I put a big black box around it on the front.
Could you do it as sine?
Could you do it as a quotient rule inside a chain rule with its own chain rules? You could if you don't like yourself, but you don't want. But you don't want to do that. Max, it'll work, but you really don't want to. She wanted to know, could she call this sine 4x over cosine 4x? And you could, but now you have a quotient rule inside your chain rule that has its own chain rules inside it, and it's just yuck. It'll look like math barfed on the paper. Let us track down f prime of x. Peel the onion, start with the outermost structure. The derivative of any e function is. Rewrite the e function. And then multiply by the derivative of its exponent. Well, that's the red thing. The derivative of the red thing, derivative of tangent, is 1 over cosine squared. Yes, the derivative of tangent being 1 over cosine squared is in the reference sheet. But this itself has its own derivative, but it won't be on the bottom. The derivative of the purple stuff is just 4. Like that. So the E thing is the top of a fraction, and the 4 is the top of a fraction. Alberto, you were about to ask a question about why they're on top and not on bottom? No, so the derivative of any E thing, if this, I'm going to write it down here, and I'll even do it in the same colors. E to the f of x, if you try to take the derivative of that, what you get is e to the fx times f prime of x. That is the derivative of any e function when it's following the chain rule. Now what we had up here was an f of g of x, because we had a function inside this f of x. So our chain rule was e fx times f prime x times g prime x. Well, no. 1 over cosine squared is its derivative. Now, tangent directly equals sine over cosine, but its derivative is 1 over cosine squared, which is what we found on the other side of the page. Okay? All right, and since we brought this up, I just want to show you guys what would happen if you had just the letters, okay? If we did f of g of h of x, this is what we've been doing right now. When we have functions inside functions inside functions. Yeah, Gavin, go sit down. I'm not done yet. This is what we've been doing. We've been finding the derivative of this when I was forced to use 3 colors. So when you do that, it's derivative of the outside, but you don't do anything to any of the inside. Then it's times derivative of f's inside. F's inside was g. So now we have g prime of, but you don't touch its inside. And then you do times the derivative of g's inside, which is h prime of x. This is what we've been doing when we had to use 3 colors. And even though Gavin thinks that this is more confusing, there must be a reason why I showed you this in the notes.
Stop.
I'm just saying. Oh, let me remind you, I finished making your test last night. There must be a reason why I have this in your notes.
I just wrote it down.
When's the test again?
The test is next week. We finish the learning the unit tomorrow. Tomorrow is Thursday. Test on Tuesday.
Thursday? You mean Wednesday?
Test on Tuesday.
Thursday.
Because we'll review Friday, Monday, test Tuesday. And there we have it.